In this lesson, we're going to discuss integer arithmetic. So first of all, let's talk about multiplication. There's two rules for multiplication. The first rule is that the product of two numbers having the same signs is positive. So the product, that's when we multiply, two numbers having the same signs, we're going to get a positive. So let's look at some examples. Of course, when we multiply two positives, 3 times 5, 15. And let's do another one. Actually, 3 times 5 we already know how to do. We don't really need the rule, but notice because the numbers have the same signs, when we multiply them, we're going to ignore the signs and we get a positive answer. The rule works with two negatives as well. So with negative 2 times negative 12, we're going to get a positive answer. 2 times 12 is 24. By the way, multiplication and division are opposites, so the rules are also going to work the same way for division. So the nice thing about multiplication and division is you just have these two simple rules and they're always the same. So of course if we divide two positive numbers, we're going to get a positive here. Let's see, we're going to get 8. And if we divide negative 72 by negative 8, again we're dividing two negatives. 72 divided by 8 is 9, and our answer is positive, and so that's going to be our answer, positive 9. Alright, let's move on to the other rule. The product of two numbers opposite in sign is negative. So a negative times a positive is going to give you a negative, for example. So 4 times negative 8 is going to be a negative number. Since 4 times 8 is 32, we get negative 32. Hold on, let me change colors here. Let's see. So we get negative 32. And negative 7 times 9, of course, we get 63 when we multiply those two numbers. And because it's a negative times a positive, it'll be negative 63. Again, it's the same thing with a quotient. If we divide, negative 16 divided by 2, that's going to be a negative number, so we'll get a negative 8 here. And let's do one more. Notice we can also use a fraction to indicate division. In fact, in algebra we do that a lot. So here we're going to get negative 9. Alright, let's move on to addition. Now addition's a little bit more complicated. There's two rules again. The first rule, to add two numbers having the same signs, we're going to ignore the signs, we're going to add the two numbers, and we're going to use the sign of the two numbers. Alright, so let's do that. So here we have two positives. So we're going to ignore the signs. We add the numbers. We get 12. And we'll use the sign of the two numbers. They're both positive, so we get a positive 12. And let's do one more, or another one. Of course, 8 plus 7, we're going to get 15. Again, the rule works with positives, but that's not all that interesting. It's when we're working with negatives that we need to understand the rule. So again, we have two numbers with the same signs, so we're going to ignore the signs. 5 plus 2 is, let me change colors here. And we're going to add 5 and 2, which is 7, and use the sign of the two numbers, so it'll be negative 7. And let's do one more. Notice sometimes we'll, like with negative 5 plus negative 2 here, I put the signs kind of high. We can also use parentheses to help us indicate we have two negative numbers being added. Notice you do have the plus in between these two numbers. Negative 8 plus negative 4, we're going to add 8 and 4 because we're adding the sign of the two numbers. Or adding the two numbers, ignoring the signs, so we're going to get 12. and since they're both negative, we get negative 12. Now when I do these integer addition, I think in terms of debt. For example, hold on just a second. If we think in terms of debt, if you have a debt of $5 to your good friend and another friend you owe $2, then you owe a total of $7. If you owe somebody $8 and you owe someone else $4, then you owe a total of $12. So if you think in terms of debt, addition is very reasonable. Let's move on to the other rule. So think in terms of debt. To add two numbers having opposite signs, again we're going to ignore the signs, subtract the two numbers, and use the sign of the bigger number. Now the key word here is to subtract the two numbers. So let's go ahead and do an example. So here we have two numbers that have opposite signs. So we're going to subtract, we're going to use 5 minus 3, which gives us 2. And we're going to use the sign of the bigger number. Well, 5 is bigger than 3, and its sign is negative, so this will be negative 2. On the next one, let's see, we have negative 6 plus 9. So again, we have opposite signs here. So we're going to subtract 9 minus 6 here. Again, we're ignoring the signs, basically finding the difference in the numbers. 9 minus 6 is 3. And then we'll use the sign of the bigger number. Well, the 9 is bigger than 6, so we're going to use its sign. So our answer is positive. Let's do one more of these. Here we have 2 plus negative 8. Again, we're adding two numbers with opposite signs. So we're going to subtract 8 minus 2, and we get 6. And the bigger number is 8, so we're going to use its sign. So we get negative 6. Alright. Whoops. I need to go back. Okay, so I want to mention one more thing. Again, if you think in terms of debt, if you have $3, but you owe 5, you owe more than you have. So it makes sense that you're going to be in the hole $2. If you owe $6 but you have 9, well, you could pay back 6 of those dollars and you'll still have 3 left. If you have $2 and you owe $8, well, you owe 6 more than what you have, so you're going to owe $6. That'll be your answer. We'll talk a little bit more about that later. But again, if you think in terms of debt, this makes a lot of sense. Let's move on to the next rule here, and that's for subtraction. Only one rule for subtraction. Basically, we're going to change our subtraction problems to addition problems. To subtract a number is the same as adding its opposite. Now, for some of you, you may be better with integers and you may not need the rule, but especially for people that have problems with working with negative numbers, this is a great place to start. This is where we usually start when we teach integers. So here we have 5 minus 2. So I could rewrite that as 5 plus, and we were subtracting a positive 2, so now we're going to be adding a negative 2. So the minus becomes a plus, and positive 2 becomes negative 2. And then now we can just use our rules of integers. We know that since they're opposite in signs, we're going to take 5 minus 2 to get 3, and we'll use the sign of the bigger number. That's the 5. So our final answer is 3. On the next problem, we got 7 minus negative 3. So that becomes 7 plus. The opposite of negative 3 is positive 3. So we're going to get 10 here. Let's move on to the next one. Negative 4 minus 8. That'll become negative 4. The minus becomes a plus, and the 8 becomes a negative 8. And we know if we have two numbers that we're adding and they're both negative, we're going to add the two numbers, again ignoring the signs. So 8 plus 4 is 12, and we'll use the sign of the two numbers. And let's do another one. This becomes negative 6 plus, and the opposite of negative 7 would be positive 7. And so here we're going to subtract the two numbers. 7 minus 6 is 1, and we'll use the sign of the bigger number, which is the 7. And so it's going to be positive 1. All right, let's talk a little bit about understanding these rules. So understanding integer arithmetic. So we're going to think of a green circle as being worth $1. And I don't know about you, but when I was young, if I borrowed money from my sister, which I sometimes did, I had to give her IOUs so she could get me to pay her back later on. So here we're going to have an IOU of $1. So red chips are $1 in that you owe. All right, so let's talk about integer arithmetic now. So basically, negative 2 plus negative 4, think of it as you have a debt of $2 and you have a debt of $4. So does that seem reasonable that you have a debt of $6 or you owe $6? So your answer is negative 6. And again, if you add 2 and 4, you get 6 and use the sign of the two numbers. That's the rule, but that's a little bit of the why. Let's go on to the next problem. 2 plus negative 5. So I have 2 green chips because I have $2 basically, and I owe $5. Well, notice that I can cancel out two of my dollar debts with the $2 that I have, but I'm still going to owe $3. So notice here we get negative 3. And let's do one more. Negative 2 plus 5, so very similar to the last problem. So I owe $2, but I have $5. This time I have 2 of my dollars that cancel out my debt, and this time I actually have $3 that I'm in the positive, so my answer is positive 3. So I want you to notice something here. If you're not careful, it's very easy to get things mixed up when you're doing multiplication or addition. Notice here that when you add two negatives, you get a negative. If you were to multiply two negatives, we know we get a positive. So be careful with these rules. Notice when you add a positive and a negative, sometimes you can get a negative, and sometimes you can get a positive. When you're doing multiplication or division, you always get a negative when you have opposites. So be really careful with your rules, and it's really important that you get comfortable and that you're not making mistakes when you do additions mixed up with multiplications and divisions. And let's talk about multiplication just for a minute here. 3 times negative 2, think of it this way. If you owe 3 people $2, then you owe a total of $6. So a positive times a negative equaling a negative is very reasonable. If you had a negative times a positive, you could just switch the order and do something like what I did here. Now, a negative times a negative is a little bit harder to understand or to explain. So I got a pattern here. If you look at it, just keep multiplying negative 2 times 3, then 2, then 1, then 0, and so on. If you look at these numbers here, we keep getting bigger by 2. So if you follow the pattern, you would get 0, then 2, then 4, and so here we would get 6. So based on the pattern, you can see a negative times a negative is a positive. The other way you might think of it is if a positive times a negative is a negative, it seems reasonable that two negatives would have a different sign. And that's the end, guys. Great job.